Alright, so you guys were asked to graph the function g of x equals 1/2 to the negative x power. We talked about how to simplify the negative exponent. I just distributed, and then the negative exponents were changed places, and then 1 to the x power is just 1 when you put in either negative or positive x values. And you get basically you're graphing to the x power. And then I asked you guys to make a table of values with 5 points. If you did put those in algebraically, meaning by hand, you just put in -2, then 2 to the -2 power. All comes downstairs, so you have 1 over 2 squared, which is 1 over 4. And you put that in your calculator, you get 0.25. If you put in -1 to your x value, this goes downstairs, so you're left with 1 over 2 to the 1. 2 to the 1 power is just 1/2, and 1/2 is 0.5. You put in 0 there. Anything to the 0 power is 1. Put in 1 in there. 2 to the 1 power is 2. And then you put in 2. 2 to the 2 power is 4. Raise your hand if you got those. Let's double check with our calculator. That looks nice. You kind of want to know what's happening, right? Okay, so let's just say you're not sure. Look here. Go to y equals. Parentheses, alpha, y equals 1/2. Uh-oh. Parentheses, caret, x. No, negative x. Let's just say you don't think your algebraic expressions are equivalent. If you just go down and graph this one, so 2 caret x and then I'm just going to press zoom 6. What should our graphs be? Different or the same? Comes the red. And that's how you know your expressions are exactly the same. So you can actually even check your answers of the algebraic that's on the whiteboard if your graphs are exactly the same. Okay? How do I get to a table? Well, you can go second window to make sure your table's set. And it does not matter where the graph starts. Some students just ask me what happens if my numbers are all weird. You want your table set to change by ones, or you can change that by halves, 0.5s. You can either do auto and ask for the first one. I'll just do auto, press enter, and then I'm going to go to my table by pressing second graph.
So your calculators are better thing.
Thank you, Caesar. And then if you notice, all my numbers should match up. Do you see the advantage of having both? What does the blue one show me? Fractions. Because I have a fraction in there. And the second one has what? Decimals. Okay, let's go ahead and graph it. We already saw a picture of the graph. Okay, as you're making your x and y axis, think ahead. What is your largest and smallest x values? Well, we're kind of around the origin, so I have -2, -1, 0, 1, and 2. And I'm just going to put in one number there. That's to show that each box is worth 1. Class, what is our largest y value? 4. Okay, so what does that mean? You kind of want to make your scales kind of nice, right? So I'm not just going to put that one as 4. Maybe you count every 2 is worth 1. 2, 3, 4. Does that make sense? 50 cents, $1, $1.50, $2, $2.5, $3, $3.50, $4. Okay. The other day we took some notes. Put your finger on the most important order pair.
0 and 1.
What is this called, class? The y-intercept. Let's go ahead and put our points. -2, 25 cents. So that's 50 cents. That means in between would be 25. Now, someone asked, why do I have to put negative numbers? Because you kind of want to see the behavior of the graph going towards the left. -1, 50 cents. 0, $1. 1, $2. And then 2, $4. Everyone say pencil. Show a pencil. Everyone say smooth. Everyone say smooth. If yours is not smooth, bad for you. Let's review. On this one, put your finger on the B value. Greater than 1, less than 1. Growth or decay? Growth. Put your finger on the A value. Show your partner. Give him a head nod. It's not there. What number is it, class? 1. Y equals ABX. A is your y-intercept. Let's make that obvious. This is a 1. Okay? One other number I need. This is way back. In the brown box, put your finger on the D value. Craziness, right? Plus 0. Pay attention. I kind of need this for tomorrow's lesson, so might as well just show you. Plus 0 tells us if it moves up or down, the transformations. So tomorrow's lesson is the transformations, but for exponential graphs, why is that important? Is that 0 represents our, is this horizontal or vertical? Horizontal. It's a horizontal asymptote. And so what that does, it kind of helps us figure out where does the graph start and where is it approaching and where can it not go.